Hello, I'm George Malim, the Managing Editor of IoT Now, and welcome to today's webinar. The topic of today's webinar is data security in the age of IoT, threats and opportunities. Obviously, security is a massive issue across the entire Internet, but in particular in the Internet of Things. I'm delighted to welcome our speakers today. We have Ilan Reingold, the Head of Business Development and Strategic Alliances at Altair Semiconductor, and we're joined by his colleague, Avishai Shraga, the Head of Security, also at Altair Semiconductor. I'm now going to hand over to Ilan, who has a presentation to give to you, and I look forward to hearing from Ilan. Ilan, over to you.
Thank you, George. Hi, everyone. So as the Internet of Things continues to bridge the gap between the digital and the physical world, it brings with it a threat of a new set of remote attacks with potentially far-reaching ramifications. Contrary to our experience with computers and mobile phones, in which attacks were focused on digital assets and devices, and the risk was about stealing data, the IoT includes the additional risk of high-impact attacks on our physical world. And you can see some examples on this slide, and I'll move on to the next one. So let us provide several examples. So, for example, a smart car can be hacked and the control can be taken, or the brakes can be cut off in a vehicle that's in motion. Another example is altering medical and automated drug dispensing devices, actually altering the treatment of these medicines. In production facilities, sabotaging devices by configuring them incorrectly or draining the batteries of different devices can cause significant damage. In the case of smart meters, for example, there are several possibilities. These devices can be hacked for defrauding utility companies with wide-scale forged smart meter readings, and I'll get to this example later on. In the case of cameras, of security cameras, using security cameras can be done to determine when a building is empty, for example, or taking personal pictures of someone without his knowledge for blackmail. And there are more and more similar examples. So basically, there are three areas where IoT attacks can occur. And we'll get to the first one, which is attacks on the IoT service. So a theft of a service is a principal risk, as in the case of smart metering, attacking the service itself has an economic value, resulting in the permanent denial of service through killing a meter and forcing the utility company to send replacements or truck rolls. Illegally obtaining vendor intellectual property also poses a major threat, such as device algorithm being reverse engineered to reproduce a competitive device at a fraction of a cost. With sensors collecting vast amounts of data and transmitting it to a server, business espionage, including data harvesting and the elimination of privacy, is a particularly significant threat with potential for dishonest organizations to gain unprecedented insight into their competitors' customers and services. So this is one area where attacks can occur, and this is actually attacking the service through the user interface or through the cloud or through the connectivity interface, resulting in loss of service or damage to the devices.
Okay, thank you, Ilan. Now on to our first survey question. The question is, how important is security within your plans for IoT offerings? And the possible responses are, it's a top priority, it's an important consideration, it's somewhat important, or you hadn't really considered it important at all. And I'll just repeat the question. How important is security within your plans for IoT offerings? The first response, it's a top priority. The second response, it's consideration. The third response, it's somewhat important. And finally, you hadn't really considered it as being important at all. And while we're waiting for the results, I just urge everyone listening to use the question box. We'll be putting questions to the panel at the end of the presentations, and we're obviously keen to answer your questions today, so do use that function. Now, let's move on and look at the poll results. That's unsurprising that a large proportion rate security as a top priority within their IoT plans, with 57.9% of respondents saying it's a top priority. I think also quite interesting is that absolutely no one hasn't considered security at all in relation to IoT. Ilan, what are your views on the outcome of the poll?
Yes, this is not surprising, and we've been expecting this result based on our interaction with our customers and the operators in this space. It's obvious that security in the IoT world is top priority for most of the players, and definitely for the tier one players, including device vendors, cellular operators, other connectivity providers, module makers, you name it.
Yeah, sure. Right across the entire industry, it's obviously a serious issue. I'm kind of interested that 40% didn't see it as a top priority. I guess they've got other technical concerns that they think edges out security, but looking at the top two responses, I mean, that's 98.3% of respondents that rate security either as important or a top priority. So I guess the message is getting through quite satisfactorily. Anyway, Ilan, I'll hand back to you now to continue with your presentation. Thanks very much.
Thank you, George. Let me relate to the 40% that did not rate this as a top priority. There is a perception in the IoT world that security actually protects for the value of the data that's being carried by the IoT device. But as we saw, the security damages or damages of lack of security can be far more expensive than the value of a single device that's being hacked, due to the fact that hacking a device or hacking multiple devices can actually damage the entire service, as we've seen. Going on to this slide. This slide actually describes the second way of attacking an IoT service, which is actually attacking the network through the IoT devices themselves. And as we've seen in the recent denial of service attacks in the US, multiple devices were accessed at the same time to bring the service down, causing lack of service, causing system outage, and many more damages. And this was done by sitting bots in the devices to attack the servers in a coordinated way at the same time, and which actually worked. And the third way of attacking an IoT service is actually, or causing a damage to an IoT service, is an actual attack on the IoT devices themselves, which can cause breaking devices, causing them permanent malfunction, forcing truck rolls, expensive equipment replacements. So you can see some examples here. And again, attacking on IoT devices doesn't have to be directly on the devices themselves. It can be done through the user interface or through the network or through the connectivity interface. Moving on to the various challenges that we see that relate to IoT security. So the IoT security challenges span through various realms, including technologies, business, ecosystem challenges, as well as regulation. The IoT ecosystem is pretty much diverse. There are numerous vertical markets, from wearables to smart city to automotive applications, etc. The IoT ecosystem is decentralized, unlike in legacy cellular services, for example. And applications can be owned and designed by practically anyone. You can take a Raspberry Pi board, connect it to a cloud platform, and you have an IoT service up and running in less than a day. Most IoT developers have little to nothing in terms of understanding of what is security and how it works and how to develop it. And devices are typically low cost, easily made, bought and installed. So there's this ecosystem is not built for the level of security and for the investments that the security levels that we're accustomed to require. The second challenge that we see is tangibility. Since security in IoT is as critical as power, cost, but it is much less tangible. Until you're hacked and you lose your reputation or you lose your service, it's not really obvious what you need to do in order to protect your service. Security is expensive and therefore it is mistreated, as we've explained before, and it becomes tangible only after a damage has been caused. The third challenge in security, for security in the IoT world, is that legacy security doesn't really fit. IoT devices require, or IoT services require the same or higher level of security compared to legacy devices. But at the same time, off-the-shelf security solutions in terms of technology, in terms of IP and stacks that are available in the market, these require significant power, performance, memory, which is not aligned with the low cost, low power requirements from IoT devices. So this contradiction is a challenge that has to be solved. The other challenge here is that the IoT market moves much faster than the security regulation advances, and this may be a fourth challenge. The other challenge here is the absence of trust. Different business entities can be co-located and use the same IoT device to offer different services. And these entities can reside in that device without inherent trust between them. And the IoT device's trust solution must be scalable to support multiple IoT service providers, multiple connectivity providers, multiple device management entities, etc. So at the end of the day, you have a single IoT device which serves or reports to multiple entities at multiple layers, and all that works without these entities knowing each other. Also, the IoT value chain is decentralized and does not have a clear business model among these entities. So it's very hard and even impossible to coordinate between these entities. And perhaps the solution for IoT security resides elsewhere, not in the attempt for such coordination. The way we're illustrating IoT security is like a balloon that's surrounding an IoT system. So you have the IoT devices, you have the IoT service in the cloud, you have the user interface, and you have to protect all of these entities and the interfaces between them end to end, because you never know where the pin will hack the balloon. So you actually have to surround that entire end-to-end system with full security. So the service side of this system can ask the following questions. Looking at the device, trying to authenticate the device. The service provider can ask if a user is a legitimate user of the service. Does the service protect users' confidentiality and anonymity? Will the service support recovery of compromised devices? Will a service or an end-to-end IoT system allow secure activation of new features? All of these questions have to do with the way that security is designed throughout the IoT system, through the devices, through the cloud service, and through the user interface. And there are more questions that need to be answered through a smart IoT security design, which relate to the security of the data, the way the data is communicated, the authentication of a service provider versus a device, the protection of intellectual property in the system, etc., etc. So the previous slide related to the fact that IoT security has to be designed end-to-end. But there's another important way to look at IoT security, which must also be designed from the ground up. When you approach the design of an IoT service and you ask yourself some questions in order to define how security is designed, you try to answer how to make a secure system, how to decide which features and measures to implement in terms of security, how much security will you achieve, can that be measured at all, and how much will it cost. And then you're going through a process where you analyze the security requirements top-down in several aspects, in terms of your target markets, in terms of the use cases and potential value for the attacker, and in terms of the assets and the attack surface, that balloon we've mentioned, and the other threats. And the outcome is typically a list of security measures that make the attacker ROI negative. That's what we're trying to achieve. And each measure is broken into end-to-end level requirements that span through the system lifecycle. But eventually, when you boil it down, it all depends on the hardware. Anything that's not hardware in a security system can be assumed to be hacked, to be a potential for hacking at some point in time, because memory content that's not secured can be changed if it's hacked. Code can be changed. But the hardware is the only basis for trust in a security system, as it is the only building block that cannot be changed. And so everything boils down into the hardware. And the hardware, in our case, the silicon, the chipsets, that's the basis to build a secured system from the ground up.
Okay, thank you very much, Ilan. Now we have our second survey question of today's session. The question is, how much do you anticipate spending in 2017 on security measures for IoT? The first response is less than $100,000. The second response is $100,000 to $500,000. The third response is $500,000 to $2 million. And the final option is more than $2 million. I'll read those questions again. How much do you anticipate spending in 2017 on security measures for IoT? First response, less than 100,000. Second option, between 100,000 and 500,000. Third option, between $500,000 and $2 million. And the final option, more than $2 million. I would also urge anyone listening to put forward their questions for today's panel. We've already got some in, but we'll have a decent amount of time to address your questions, and those that we don't have a chance to, we will address afterwards anyway, so do take the opportunity. Right, let's see what's happened in this poll. Okay, so there's quite a spread here. And it looks like about 50% are planning to spend under $100,000. Ilan, does that surprise you?
To some point, it does. We were expecting that we will see most of the answers here answering the second and third choices, somewhere between 100,000 and 2 million. We're not far from that. I think the explanation for the 50% for the first answer, less than 100K, is the fact that security in IoT devices wasn't that tangible for most of the IoT players so far. Security, actually all of the reasons that we've mentioned, tangibility, lack of regulation, the start of this ecosystem, it's in its early stages. I think that with time, we'll see that players in the IoT ecosystem that provide infrastructure, such as chipsets, such as cloud platforms, such as cellular operators and other connectivity players, these guys will probably answer a spending of more than $500,000 or even more than $2 million. But it's these infrastructure providers will provide smart security solutions, then other players that build IoT services or build IoT devices, and these will not have to put large investments into their offerings, because the security will be solved by the infrastructure providers. Does that make sense?
It does to me, certainly. That I was wondering, actually, with that 100,000 figure, I certainly take your point that deployments are relatively small scale for much of the market at the moment, and obviously that's affecting how much is invested in security. And I actually found it quite positive, I suppose, that more than 7% of our audience are planning to invest more than $2 million, because that suggests to me that things are scaling up and the seriousness of the security issue is understood. Because at the moment, investing $2 million in the security of a typical IoT deployment seems an extremely large amount of money, given the number of users or the number of endpoints. But obviously that will change as the market continues to mature. So I take your points there. But also I do think that it will become increasingly difficult to strip out security as an isolated investment, as you pointed out.
Right. So
okay, so shall we move back to your presentation, Ilan, or were there any other observations that you wanted to make on the poll?
I think that this, if I relate to that as a histogram, probably 2-3 years from now, that would look less. That would look with more players, say 70 to 80%, spending less than $100,000, because there will be sufficient solutions in place in terms of chipsets, in terms of cloud solutions, in terms of regulation and security solutions that match the low power and low computation performance of IoT devices in a way that would not require any significant investments from, say, a Raspberry Pi developer.
Sure. Yeah, good point.
Okay, moving on. So securing a device needs to be done through its long or very long lifespan in the case of IoT. And it starts with the device development, analyzing the threat, designing the system for security, for end-to-end security, using secured hardware, software, and other technologies, using secured measures during testing and certifications. Then it goes through the service development on the device and through the cloud and the user interface. Then you must have a secured production in order to maintain the security that you achieved through the device development phase. So you have to use a trusted production site, take care of personalization and identities through the production phase, and have a root of trust within the device, within the chipset, that you can then leverage or use in the next lifespan stages to keep that service secured. And then you deploy the device. You have to deploy it and have a secured communication, and then through the device life cycle. You can go through upgrades or recovery of devices, and then at some point that device can go through an RMA, or it can be its life can be ended. And at each of these phases, security must be kept. And unlike security as we know it today, when we talk about IoT devices, we typically relate to more than 10 years of battery life. But thinking about it, then supporting devices in the field that live for more than 10 years also implies on the way that security is defined and implemented, and also on other criteria. So this definitely defines critical requirements in terms of security through the device lifecycle. And all of these have to be related to throughout that lifecycle. To summarize all of that, from our experience, from our experience of putting all of the IoT security pieces in place within Altair, we do that through a paradigm shift to new technologies and new business models. So first of all, we handle security as a foundation. As a chipset vendor, we provide hardware-based security, which is then used across the entire device lifespan and throughout the IoT service end-to-end as the foundation for that security capability. And security is designed from the ground up, from day one when we start a design, in a similar way to how power consumption, cost, and performance are designed. The other important piece here is to support new means of security with regard to the way these are optimized for IoT. So the way that security is partitioned between the edge device and the cloud, for example, using other means which were not used until today in the IoT world for broad remote detection and real-time response capabilities to various threats, and partnering in order to provide cost-efficient security and IoT optimized regulatory compliance. And the third piece here is what we call smart IoT security, or zero friction security. Security needs to simply work, and the less it requires from various players that use our chipsets, the higher value Altair provides in terms of security. So this is also one of our goals. And keeping the device secured for more than 10 years of life requires some measures that must be related, must be considered. So all in all, vendors that are willing to design devices and invest in solutions to address future threats and attacks, we see such vendors in stronger market positions. But certainly, IoT security needs to be considered and related to in a special way that's different from the way that legacy security was related to. George, back to you.
Okay, thank you very much, Ilan. That was a very interesting presentation. I'd now like to open the floor to questions and answers. We've already had several questions in, and we'll start answering those soon, but there is still time to submit any questions that you have to today's panel. The first question I've received has come in, and the question is, can you please let me know who are the vendors who are providing the hardware protection? Ilan and Avishai, I don't know which one of you would prefer to take that one first, but I think the point here is about the hardware, because the question has hardware in inverted commas in it.
Altair is designing its own chipset. So the answer to this question is simple. We're actually providing and designing the hardware, including the security foundations that we related to throughout this presentation.
Okay. So moving on to the next question, which has come in, and the question is, does connecting a device with highly security-focused hardware, such as a smart meter, to the same network as a device that is less secure, undermine the security capabilities of the first device?
That's a good question. And we've seen such examples. If you think of it, this use case will be a typical use case, actually, because you always have legacy devices or older devices in the field, and you upgrade or replace or deploy new devices in a gradual way. So at any point in time, your system or your network has old devices, new devices, and devices somewhere in between. And a smart security design supports the full security performance or features of the new devices, regardless of the low security capabilities of older devices. And this is definitely something that we've experienced and we've proven with our design. So that's possible.
Okay, that's an interesting one. Next question I have is, we understand that security foundations must be implemented in the chipset hardware. How does that affect the cost of IoT devices?
So the short answer is no effect, actually. Yeah, that's a simple answer. And the amount of silicon that's required for that security foundation is actually negligible compared to the amount of silicon that you need in the device anyway, for the modem part, for the processing part. Security actually doesn't require that much.
Okay. So another question has come in, and it's when you were talking about zero friction IoT security, Ilan. The questioner wants you to expand more on the idea of zero friction IoT security and what that really means.
Sure. So zero friction actually means that you don't have to do anything that relates to security when you design a device, when you manufacture a device, when you deploy a device. You don't need to understand anything that relates to security. You don't need to write any security-related code. You don't need to establish any secured connection. Simply, you don't need to do anything. And consider, for example, a gas meter that needs to be secured, but is designed and manufactured by a gas meter company. It would not make sense to require these guys to start understanding something that relates to IoT or to network security. That's not their forte. That's defocus from their core business. And if they would be using a chipset or a software that's doing all of that for them, and they actually don't need to do anything or know anything about security and still get the right amount of security, if we can relate to that, to quantify that, then that's true zero friction security.
Okay, great. Thank you very much. Next question we've got is slightly off the security topic, but I do think that's part of device stability and ultimately being able to operate devices, so I'm going to ask it anyway. The question is your hardware able to handle extreme temperatures and weather and other factors, and is there a way to update your hardware over the air?
So yes and yes. Our hardware is already being deployed in the harsh outdoor conditions. And certainly firmware upgrades over the air, or as we call it, FOTA, that's a basic feature or basic functionality that is supported.
Okay, that's very interesting. With the over-the-air capability, do you see that being used for IoT security at any point, or do you think the over-the-air capability actually creates a point of vulnerability?
No, over the air, everything that happens over the air, from data to device management to software and firmware upgrades to device recovery, all of that is being done in a secured way. It must be done in a secured way.
Sure. So that's one of the difficulties that I grapple with when you start thinking of upgrading devices over the air. You think about the potential for those communications to be hacked and the device to be hacked during that upgrade process. But if it's properly encrypted and the security is maintained end to end, are you relaxed that the over the air upgrade approach is secure?
Hello, everybody. I will take this question.
Hi, Avishai.
Hello. In the world of security, I don't think that using the word relax is appropriate. We can never be relaxed, but we need to do a very good analysis and put in place the right protection mechanisms in order to ensure to the highest degree possible that it is not hacked. At the end of the day, every device in all of our computing world needs to have inputs and outputs, whether it's network communication or software upgrades or other means of inputs and outputs, and all of these are potential way to hack the device. And this is why we explained that during the presentation that the device needs to be designed for security, and security is not something that can simply be added at the end. And if you do the right analysis from the beginning of what is your potential attack vectors and what is your attack surface and what are the threats, and you put the right means in order to protect it, then you can have a high assurance that it's protected. And I think the main thing to understand here is that we are not targeting, or I don't believe anyone in the security can target a non-hackable device. What we should target is that the ROI of the attack for the attacker will be negative. So if the cost of the attack is more expensive than the potential value, it's not reasonable to hack. And this is, the means that we are putting in firmware upgrades and in all other potential risky flows.
Okay, great. Thank you. We'll move on to the next question now, which is how have you balanced the high performance and high cost of security with the low performance and low cost requirements of most IoT devices?
The way to balance that is to partition. One of the ways we've approached this is to partition the amount of processing that's done at the chipset level, at the edge, at the device, versus the amount of security that's being processed in the cloud. And the smart interface between the device and the cloud to enable responses to threats in real time, but at the same time without requiring significant data transfers or data throughputs in order to do that, and in a way that does not increase the processing power that's required from the device.
Okay, excellent. Thank you. The next question we've got is, what is the end-to-end industrial security standard for AMI application for telcos in particular?
Can you repeat that question, George?
Yep, sure. It is, what is the E2E industrial security standard for AMI application for telco?
In fact, we're handling our various industry standards and methods for security, but we didn't cross that term.
Yeah, it's new to me as well. I'm not sure what the AMI acronym stands for, which makes it a little bit difficult to answer the question. So maybe we'll come back to that later, or maybe the questioner could get in contact with us and explain that so we can approach it. Next, let's take a different tack. Another question has come in, and the question is, I had the impression that 10 years was used as an IoT benchmark for battery life, but now I see it has more implications. Can you share your thoughts on this?
Sure. When you think of devices that would live in the field for 10 years or even 15 years or more, then this certainly relates to the battery life of the device, if that device is battery operated. But it also implies that IoT devices must have sufficient amounts or levels of flexibility built into them in order to support the various changes that can occur in terms of security threats, security protocols, security methods, but also in terms of connectivity solutions or connectivity providers that can change with time. In other words, it's not only about long battery life, but also about flexibility in that device in terms of connectivity and security.
Great, thank you very much. While you've been talking, I've learnt something. One of our audience has let us know what AMI stands for, and it stands for Advanced Metering Infrastructure. So let's revert to the earlier question, which was, what is the end-to-end industrial security standard for advanced metering infrastructure?
So we've learned something new, and we'll certainly look into that.
Okay, we'll get back to the original questioner after the event. We're learning all the time, and hopefully so is the audience. So that's a very good thing. We have another question that has come in. It says critical infrastructure industries tend to focus on the threats that are presented by IoT, but what are some of the positive use cases for IoT devices that industries like the energy industry could benefit from?
We missed the last part of the question. Could you repeat that?
Sure. I think the question is saying that there's a lot of negative thoughts about security for critical infrastructure, particularly with IoT and critical infrastructure. But they wondered if there are some positive use cases for IoT devices that industries like smart energy could benefit from.
The fact that IoT security is doable and it's already implemented today actually enables IoT solutions as a whole. And with that in place, you have the entire spectrum of positive values and benefits that you can gain from IoT applications, also in the utility and energy vertical. So I'm not sure if that's the expected answers, but overall, the fact that security is doable and it enables the IoT market and application.
Okay. Fine. Let's move on anyway. Another question that I have is, it's quite a wide question, so I think it will give a good opportunity for a strong answer. The question is, what provisions for threat or breach detection should be in place for IoT deployments?
So I think, as you mentioned before, the IoT device is a very low power device, and you want to do minimal work on the edge side from one hand, and to have good protection on the other end. And therefore, you want to collect minimal amount of data in the IoT device in order to be able to identify misbehavior or anomalies. So what you would like to do is probably identify and collect a minimal amount of behavioral characteristic of the device, both in the application level and in the connectivity level, and report them to a central place where they can be actually analyzed and the decision can be made.
Okay, thank you. I think we've probably got time for one, maybe two more questions left. So I'll ask a quick and easy question. Well, I think it's easy for you to answer. It may turn out not to be. The question is, are you designing with a PKI infrastructure from the chip to the end device?
So basically, we are using a PKI infrastructure in some of our design mechanisms. I'm not sure what it refers to from the chipset to the device, but end-to-end it is based. Some of the mechanisms are based on PKI. Yes.
Okay, great. Thank you very much. And I guess we're getting to our last question now. The question that we have is, are there any case studies or examples that you have of IoT device or service hacking that you think are particularly interesting to share today?
There's quite a lot of material in the internet that relates to IoT security. I admit that most of it is quite high level. I guess that IoT security vendors don't want to expose their secret sauce, how they get to an optimized performance, or how they partition various security capabilities. So you would find a variety of use cases, but it would be very hard to find a set of detailed examples how things are being implemented.
Okay,
it will take time before we see such information public.
Sure, absolutely. Okay, well, I'm afraid we are out of time, but I'd like very much to thank Ilan Reingold, the Head of Business Development and Strategic Alliances at Altair Semiconductor, and his colleague Avishai Shraga, the Head of Security, also at Altair Semiconductors. It's been a fascinating discussion, and I'm sure it's an area that we're all particularly interested in because it's so fundamental to the success and safety of the Internet of Things. So thank you all for sparing the time to listen to the webinar today. The webinar will be available to listen to after we finish the session at iotnow.com. I'm George Malin, the Managing Editor of IoT Now. Thanks very much for participating today. Goodbye.
Thank you very much. Bye-bye.
Thank you. Bye.